Hi everyone. In today's lesson we are looking at Chapter 7, Section 2, Reflections. Our objectives are to identify reflections in a plane and to identify relationships between reflections and line of symmetry. Our standards are G code 2, 3, 4, 5, 6, 7, and 12. Here's our vocabulary words. First word is reflection. A reflection is a type of transformation that uses a line that acts like a mirror with an image reflected in the line. Line of reflection. In a reflection, the mirror line is called the line of reflection. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. If you think about it, when you have a straight line and a line that intersects it, in order for the two angles created by the intersected line to be congruent, there's only one way for that to happen, and that's if you split the angles in half. Linear angles are equal to 180 degrees, so in order for these to be congruent, this has to be 90 degrees and this has to be 90 degrees. The notation for perpendicular is this upside down T, and this is saying that G is perpendicular to H. So know this notation here stands for perpendicular. Perpendicular bisector. A perpendicular bisector is a segment, ray, line, or plane that is perpendicular to a segment at its midpoint. In our diagram over here, we have a segment AB that is bisected, which means that it is cut in half by a perpendicular bisector, and the midpoint is at D. And you can see over here we have a right angle created by this perpendicular bisector. If we are given the x and y coordinates and asked to reflect it across the x-axis, all you would do is take your original x and y and just change the y to its negative. So what it looks like would be x and negative y. Here's an example. So if our original points are 3 and 5, when we reflect it across the x-axis, our new point would be at 3 and negative 5. If we are reflecting the points x and y across the y-axis, again, we're going to keep it as x and y, but this time we're going to change the x to its opposite. We would have negative x and y. So an example of that would be if you're taking 3 and 5 and reflecting it across the y-axis, then we would get negative 3, 5. Also remember that a reflection is an isometry, meaning it does not change its size. Example 1, reflections in a coordinate plane. Graph the given reflection A, J38 in the y-axis. So what we need to do is reflect the point 38 across the y-axis. So let's first plot 3 and 8. There we are. And notice we are from this point 1, 2, 3 points away from the y-axis. So if I were to reflect it across the y-axis, I'm going to go 3 points across the y-axis. So 1, 2, 3, and my new point is located at negative 3 and 8. Because J is 3 units to the right of the y-axis, its reflection J prime is 3 units to the left of the y-axis. B, K is at 7, 4 in the line x equals 7. So what we really need to do is reflect the point 7, 4 across the x equals 7 line of reflection. So first graph and label K and the line x equals 7. So here's x equals 7 and here's K at 7 and 4. Now, since we are reflecting across the line x equals 7, which is exactly where the x coordinate of this point, it just basically implies K is on K prime. So there's really not much reflection to do over here. All right, checkpoint problem number 1, 2, 3, and 4 are yours. It says graph the given reflection in the coordinate plane, label each image. We've got 1, A is at 0 and 2 in the x-axis, so you're reflecting across the x-axis. 2, B is at 5 and 1, reflecting across the y-axis. 3, C is at negative 4 and 3 in the line x equals negative 3, so you're reflecting across the line x equals negative 3. And D, 4 and 0 across the line y equals 2.